Okay, so another way to solve system of equations is by something called elimination. We've already talked about graphing the two linear equations and figuring out where they intersect each other, but in order to graph it, both equations had to be in slope-intercept form. Then we talked about substitution, where you needed one of the equations to either be in slope-intercept form or to have that x isolated on the left by itself. For elimination, you don't have to do that. You don't have to mess with equations that are in standard form. You actually probably would prefer them to be in standard form. So here I have two linear equations, both in standard form, but the number one thing that you want to look for is you want to look for one of your variables. You want to hope that they would have the same coefficient. It doesn't matter if it's x or y, but you want one of them to have the same coefficient. So obviously my x's do not have the same coefficient here of a 3 and a 4. And really my y's don't either, because I have a positive 4 and a negative 4. But not only do you want to have the same coefficient, you want to have opposite signs, okay? So we really want the same coefficient with opposite signs, which we have here. So my y's work out perfect because they're both 4s, one's positive and one's negative, and that's exactly how you want to be set up for elimination. So for elimination, we're going to take our two equations and we're going to turn it into a really big addition problem. And we're going to add vertically, just like you would add a 2, 3, 4 digit number. So I'm going to say 3x plus 4x is 7x, and 4y plus negative 4y is just 0. It cancels or eliminates. So the whole point of having the same coefficient with opposite signs is for this reason, so that they will completely eliminate each other. So I have eliminated all y values completely. So then I say 2 plus 12 is 14, and all I have left are some x's, which is perfect because now I can solve for that x. I divide both sides by 7, and I get that x equals 2. Well, there's half of my answer already. So remember, your answer is a point, which is an x and a y value. So my solution is 2 comma something because x is 2. I'm not sure what the y value of this is going to be yet. I'm going to have to do a little bit of math to figure it out. So what I'm going to do is I'm going to choose either the first or the second equation. It doesn't matter which one. And I'm going to take 2 and I'm going to plug it in. So let's choose the top one. So 3x, but x is 2, plus 4y equals 2. So that's 6 plus 4y equals 2. So that's 4y equals negative 4. So y is going to equal negative 1. Okay, and that's just one variable, simple equation that you can work out. So I get that y is negative 1. So my point of intersection is 2 comma negative 1. If I were to graph these two equations, this would be where they would intersect with each other. I can also check my work by taking the 2 and the negative 1 and plugging them in for x and y and making sure that it equals 2. And then plugging it in for x and y here and making sure that it equals 12. Because this point should be true. It should work for both equations. That's how I know it's the solution. So now let's look at what would happen if my problem wasn't set up the way I needed it to be set up. So remember, we want either our x's or our y's to have the same coefficient but opposite signs. So in this case, my y's have a 4 and a negative 6. Well, that's opposite signs, but it's not the same number. My x's both have coefficients of 1, but they're both positive. So again, neither one of these are set up the way I need them to be set up. My x's are going to be really easy to make work for me, though. So if I already have the same coefficient, and all I need is an opposite sign. So what I'm going to do is I'm going to take one of these equations, and I'm going to say, well, what could I multiply that whole entire equation by to get me what I need? So in this case, I want this top x, I want it to have a negative sign in front of it. I still need it to have a 1 because this one has a 1 coefficient, but I need it to be negative instead of positive. That way they can be opposite from each other. So the way that I can change this sign to a negative is by multiplying everything by negative 1. When I do that, I'm going to actually multiply everything inside of these parentheses by that negative 1. I'm going to distribute that negative 1. And I'm going to end up with negative x minus 4y equals negative 11. So now my x's are set up for exactly what I need with elimination. They have the same coefficient of 1, but they have opposite signs. So I'm going to turn those two into an addition problem, just like we did previously. So x plus negative x, well, that's going to eliminate or cancel out my x's, which is exactly what I want. Negative 6y and negative 4y make negative 10y. And 11 and negative 11 make 0, which is perfectly fine. I continue my process of dividing by negative 10, and I get that y equals 0. And there's nothing wrong with y being 0. Remember, 0 is an answer. 0 is a solution. So we know our y value is 0, but we're not sure what our x value is. So remember, I'm going to take this y value, and I can plug it in anywhere. I can go back to the very original problem inside of these parentheses if I want. I could go to the second problem, or I could go to the third problem where I did my distributing of the negative sign, or the negative 1. It does not matter. I'm going to go with this one that I haven't touched yet, just because I haven't messed with it at all. So x minus 6y, and y is 0, equals 11. So that's x minus 0, or just x equals 11. So my point here of intersection is going to be 11, 0. That's where these two lines would cross each other. I can check myself by taking 11 and 0 and plugging it in for x and y, and it should make the equation true. All right, let's look at what would happen with an equation where nothing is set up for you. My x's don't have the same coefficient. My y's don't have the same coefficient. None of them have opposite signs, so I have to do a lot of manipulation here. In order to get the same coefficient, I have a 2 and a 5. I probably would not use my x's here. I would probably use my y's because this y has a coefficient of 3, and it would be very simple to make this have a coefficient of 3 as well. I could multiply the whole problem by 3. Now that's going to fix my issue of not having the same coefficient, but remember, we want the same coefficient and opposite signs. So if this is a positive 3y, I really need this to be a negative 3y, so I really need to multiply by negative 3. You want to make sure, I see this mistake a lot, you want to make sure that you are multiplying every piece inside of this parentheses by that negative 3, even this last number here. So that's going to give me negative 6x, negative 3y, and negative 3 times 0 is still just 0. So in this case, it didn't change that last number. And then I'm going to turn this into a big addition problem. So I have 5x plus negative 6x is a negative x. My y's are going to cancel, or eliminate, which is exactly what I wanted. And 2 plus 0 is 2. So that means x is negative 2. So that's only half of my answer. That's just an x value to my answer. So I've got negative 2 comma something. And I'm going to choose any of these equations I want to take that negative 2 and plug into. I'm actually going to choose this one here because I just haven't touched it. So 5x, or 5 times negative 2, plus 3y is equal to 2. So that's negative 10 plus 3y equals 2. So 3y equals 12. So y equals 4. So negative 2 comma 4 is going to be my solution here. All right, our last example is going to be one that's pretty difficult because there is a lot of work you're going to have to do to get this fixed the way you want it. If you notice, my x's don't have the same coefficient, my y's don't have the same coefficient. My y's do have opposite signs, which is good. I could use that. But then I just have to decide, do I want to do my x's or do I want to do my y's? We could say that we'll do our y's just because they have opposite signs. But now I have to say, what am I going to be able to multiply these equations by to make their coefficients be the same? So if there's nothing that I can multiply 4 by in order to get 6, so I think, all right, I'm probably going to have to manipulate both of these. So you want to think of what can I multiply each of these equations by, and it can be something different to get me to have the same coefficient. So if we multiplied this one by 4, that's going to give me a negative 24y. If I multiplied this one by 6, that's going to give me a positive 24y, which could fix my problem. So again, you want to make sure that you're multiplying throughout the whole entire set of the equation, throughout the whole entire equation. So this is really going to become 12x minus 24y equals negative 12. And the second one here is going to become 12x plus 24y is going to be equal to 30 times 6, which is 180. So a little bit bigger numbers here, but you can definitely still do this. So we turn this into an addition problem, and I get 24x. My y's eliminate each other, which is exactly what we want. And then this is going to be equal to 168. So now we're going to divide each side by 24, and I get that x equals 7. So there's half of my solution already. So x is 7. We're not sure what y is, but we can take that 7 and we can plug it in. Now here's where you can plug into any equation you want. You can plug into the 2 original equations, or you can plug into one of the 2 after you've manipulated those coefficients. So we'll just plug into, it doesn't matter, we'll plug into this top equation here. So 3 times x minus 6y, and x is 7, equals negative 3. So 21 minus 6y equals negative 3. Negative 6y is going to be negative 24. So y is going to be 4. So 7, 4 is going to be where these 2 lines would intersect each other.